Okay, let's get started. Good morning, everyone. Thanks a lot for coming and attending the third workshop on security of space and satellite systems. My name is Anjan Ranganathan. I'm the co-PC chair alongside Samuel Jero from MIT Lincoln Labs. A bunch of thank yous will follow, and then we would proceed with our day's keynote. First, thank you is from the PC chair straight to the steering committee for having the trust in us to actually pull this off. By the end of the day, some of them are here, maybe at least one person is here in this crowd who might say whether we pulled it off or not. The program committee, again, thanks a lot. These days, it's very hard to submit reviews on time. They did it on time, without which you wouldn't have gotten your reviews if you are a paper author on time. So thank you all for the kind cooperation. Of course, the web chair and the publicity chair, if you have been on LinkedIn, Jesse has been proliferant on posting updates on the workshop, and Simon has been taking care of the website itself. Of course, we thank the workshop NDSS workshop chairs and the whole ISOC Foundation and the staff who have been continuously helping us set these things up. Of course, we didn't forget you folks, so thank you. Thanks to all the authors, thanks to you, all of you. We, after doing all kinds of cleanup, we ended up with 15 papers, and almost 7 papers got in. Which is 46% acceptance rate, and we are going to see two sessions, all these papers being presented in 2 blocks through the day. Logistics. First, we'll start off with our keynote address. I'm not going to go into the details because we will have a separate intro session. All the breaks are going to happen in the Pacific Ballroom D. Except the lunch, which is apparently, I've been told, is it a nice terrace and harborside place. So let's see how it goes. We will have the first paper session starting at 10:40, the first break, and then we move on with the rest of the program. Pretty much, we plan to close at 5 p.m., so we don't want to keep you folks too long here. Okay, so I let Sam continue with the rest.
Yeah, so we have 2 paper sessions, one this morning and then one at the end of the afternoon. We have about 25 minutes for each paper, so that gives about 18, 20 minutes for the talk and then Q&A. We do really want to have a good Q&A, so please be thinking of those questions, and hopefully we can have a good dialogue. One of the benefits of doing a workshop like this is that we can actually use the questions to learn from each other and get a better sense of where we as a community may want to go. Right after lunch, we're going to have a panel on the space security priority, what matters most, what is the key thing that we as a research community should be exploring in space security. And so we have a really exciting set of panelists for that. We have our keynote speaker, Ashok Prajapati, coming back to be part of that panel, as well as Martin Stromheimer, Dan Wallach, and Stephen Schwab. So should be a really exciting panel after lunch. So please don't go away and don't fall asleep after lunch. It should be exciting. Okay, and with that, we can now move to our keynote speaker. We are very lucky to have Dr. Ashok Prajapati with us to give the keynote speech today. Ashok is the CFS, NASA's Core Flight System program manager at NASA Goddard. He's also an accomplished technology leader and researcher with more than 20 years of experience across a wide variety of domains. With a solid foundation as an engineer, researcher, and people leader. He now serves as the CFS program manager and deputy software a tech fellow at NASA's Goddard Space Flight Center, where he contributes to groundbreaking research to Mars, the Moon, and beyond. Yeah, and I don't know about you, but I'm really excited about this because as we were getting into the space security domain a number of years ago, NASA's core flight system was one of the big key flight software things that we looked at. So I'm really excited to have him talk about what's coming next for CFS. With that, please join me in welcoming Ashok.
Thank you, Jim. So how are we going to switch there? Okay, perfect. Can you guys hear me okay? So good morning. I hope all of you have your coffee this morning. So once again, I'm Ashok Prajapati and CFS. How many of you heard about CFS? Quite a bit. Nice. So, sorry, I had bad throat, so I'm trying to make all efforts not to cough. So CFS, who don't know, this is NASA's one of the main flight software framework. And I think any missions you hear from NASA are powered by CFS. So any big ones, Artemis, Mars Sample Return, very recent Roman Space Telescope is being launched like next year. All these big missions, even smaller missions, like even CubeSats, lots of satellites you hear, not just in this country, but across the globe, powered by CFS. So this has been such a portable, modular architecture, and it's just so handy to use it. Like if you decide that you want to do something and you can prototype in a few weeks and say, hey, this works, awesome. So that saves a lot of your time from doing something from scratch. And plus, NASA used this about 20 years roughly now. It was born in 2020, actually 2003 roughly, so it's more than 20 years now. We had a great article recently in Space News, and also actually I did one article about the history in NASA magazines called Spark, I think the very recent one. So that I'll talk about like CFS history. So forgot to tell one thing about it. It's like it has powered about 40 plus NASA missions, like you can count on. Anything you would have heard most likely is powered by CFS, except a few. And those were like situations they decided like, oh no, something you need like bare bone application to expedite that thing. So they just skipped where you don't need an operating system. But anything you need with the operating system, usually NASA uses CFS. And based on my recollection, I have been to many such conferences, very focused on flight software space. And what I found is most likely 80+% across the globe missions powered by CFS. I was surprised myself to see that, like, hey, how this is being used. NASA did a poor job in maintaining this open source. I happily accept that. I'm trying to fix that. Past 1 year, very hard. And people were struggling, but they still used it because, hey, there's a legacy coming with this. So a little bit about my branch. This is the branch I work. It's called Flight Software Systems Branch. We do all software for all the missions across the NASA. I would not say across the NASA, but within Goddard, what are the mission being done by. So mainly satellites and some of the programs we support, like Artemis, some part, and Mars Sample Return, all that. So this is the branch where this software, core flight software was written 20 years ago. So what is CFS? I think I already mentioned this about, but this is not flight software. There's a lot of confusion about it, like, hey, this is flight software. No, this is not flight software. This is a framework that allows you to write flight software. So this provides a base infrastructure which you need to power any spacecraft, or there are various domains, not just spacecraft. I'll show you the list. The various segments this is being used. It's not just like a spacecraft. And so 20 years, we did lots of improvements. It started with like a simple application born out of a need. There were two missions that started about the same time. There was lack of resources and all that. So someone decided, like, hey, why don't we make it modular and create something common so we can save a lot of resources? So that's how the CFS was born. This is TRL Level 9 Flight Software Framework, and I think you know what TRL levels are, so it's pretty good. Very modular, so many applications already part of the bundle. So there are two things. One is called CFE, Core Flight Executive, and Core Flight Software. So Core Flight Software is a bundle, and CFE is an engine that is powering everything. So main base infrastructure is CFE that comes with software bus, some base applications. And when you create flight software, even for your small satellite, basically it comes with so many things. So you don't have to recreate anything. All that is very proven in the past 20, 25 years. So this is just ready to be used. So my last bullet says flight software with CFS. So that's what it says, like use this framework to create your flight software because it's 100% reusable. And other good part is, like, if you're commercial company and you're trying to create, or even university, trying to create any satellite and you want to write software, you'll find lots of resources across the globe to use that. A lot of knowledge already somebody has. So it's commercial companies, you can hire somebody who already knows CFS instead of like starting from zero. So you save a lot of time, a lot of like learning curve, so many beautiful benefits you get with this. To the right, this is a roughly architecture. This was 2020 Year Software of the Year Award winner for the NASA. So all the bluish portion, or turquoise, whatever you call it, this is the core piece of it, and that's my team is responsible to do that. And anything on the gray on top, that's the application layer. So this is very specific to your flight software. If you're doing satellite or creating a lander, you're creating any spacecraft, whatever you're creating, that is very specific to your mission. So you create that. But everything else in the blue comes with CFS bundle. Underneath, there's a boot layer. So we have two interfaces. One is called OSAL, that's like operating system abstraction layer. And then other is called PSP, which is very specific to hardware. And OSAL is specific to operating system, so any RTOS you're using. And we support various operating systems like VxWorks, RTEMS, free RTOS, and obviously like very standard Linux. So it's much easier to prototype. And it's created in such a way, like during compile time, you can pick what do you want to compile for. Is this for Linux system, or it's for VxWorks, or for RTEMS? You can play with the switch or CMake and compile. Same code, compile it for any of those platforms. So benefit of CFS architecture, I already told you, like, hey, these are the, like, so many things you can do with it. Very modular architecture and very easy to move around. Being an engineer, if I'm CFS engineer or flight software engineer using CFS, it's much easier for me to move around and support any missions come. So from other side, it's good for organization, like you don't have to find somebody and train it. Rather, you can like efficiently move people around without, no learning time to support your needs. CFS uses an impact. Wanted to show this slide just for little overview how this is being used. Like we have multiple mission directorates, and you can see this is being used across all mission directorates. 40 plus NASA missions, I said, Roman Space Telescope, CCRS, I don't know how many of you heard about, but this is Smart Sample Returns, Capture, Containment, and Return System. We have robots collecting like Perseverance, Curiosity, all that in Mars. They're collecting sample continuously as we instruct them to do, and they put it on sample tubes. They are just collecting somewhere. So now the turn is to just go to the Mars and bring those samples back to Earth so we can do analysis. So that's the CCRS is, and actually I was leading CCRS robotics team before I took over CFS program manager. So I myself is a big user of CFS, and few things like that's in my support. I can say that like at some point we had to make decision to move out of one legacy software for my robot. I didn't like that. Usually that's the case. You create a robot somewhere and then you want to create another one. Usually you take that software code and try to adapt it. And architecturally, other was like 12, 13 axis robot, 4 or 5 axis robot, like, hey, this is not a good idea. You're going to spend more time adapting to it instead of like recreating. And same time, you'll have a lot of complexity, lots of like memory uses, CPU uses, and ultimately what's going to happen is like we will not pass our PDRs or CDRs because for small functions, taking too much of resources and being a space, like you don't have luxury of utilizing so much resources. So ultimately, I ended up pushing it to redesign, and it took me 6 months to redesign utilizing software from zero to get the one motor spinning, following full process, like from ground to full robotic system, versus the one I was given like 2.5 years to spin the motor. So you can see from the scratch, obviously we had built up some knowledge how things are going to work, but it's a 6 month versus 2.5 years to get the same state. So that's the beauty of CFS software. And plus, a lot of help available. If somebody doesn't know anything, you can go to all those brilliant engineers who have used for 20, 30, 25 years this software. You can just go talk to them, hey, I'm having this difficulty. So all those benefits you get. We have large community. If you don't work for NASA, if somebody else and using CFS, we have large community. You can always poke questions and you get answers from all those experts. And my all experts guys are part of those email chains, and they help all the time. And not just this country, but across the globe. We have millions of users for CFS. These are a few past missions. Thought might be a good idea. You might have heard some of them. Myself did not hear a lot of them. So, excuse me. So based on actually recent report, this yellow thing talks about, this became flight software standard by Human Exploration Operations Mission Directorate. So anybody working with this directorate, basically, they created a document, call it ISWIS, and there CFS is basically flight software international standard. CFS is like open source, and I think most probably you all know that. We have made it open source many years ago, about 3-4 years ago, we made it Apache 2.0. So that gave the freedom, anybody, hey, just go clone it and own it. Anything you create beautifully, some people or some commercial companies may not want to share back. So that's how, like, we do not have any track how many users across the globe who are using. But this is the list, small subset of the list that in one way or other they reached out to us asking for help, or somehow somebody told us like, hey, we are using CFS, it's cool, and this and that type of stuff. So collected small list, but you can see the big players here. ESA, Canadian Space Agencies, CSA, I work with them directly. JAXA, Japanese Space Exploration Agency, so they also use it. So many more, including DoD. And actually academia as well, along with commercial players. So we always feel proud, like we did not do much bigger mission in the past 60, 70 years after Apollo. And very recently, a few months ago, I should not say a few months ago, maybe more than 6 months ago, IM, intuitive machine, basically landed on the moon. And if you were following the news, basically just they were about to land and some glitch happened and they could not land. So there was bug in software, the LiDAR system. So either fix that or abort the mission means you lost billions of dollars and many year worth of efforts. So that was the situation, and I heard this. Many of us heard this on their press conference. They're saying basically CFS saved our life. This life in the sense like this mission. Because CFS provides a way to update software no matter where you are, ground or in space. So what they did was basically they identified the bug, fixed it within few hours, and pushed it out from the ground and updated the system. And they were able to land. So you can see the criticality of this piece, how beautifully that design. In the first glance, you may think like, hey, there's so many things in here. There are like 20, 30 applications here. I don't need them. Why should I? And this why should I, you realize when you are in the game after a long time, you need every piece of that. And just think if we did not have that option to update the software while you're in space, basically you kill the whole mission. That made the history. So, and I think that would be the first time CFS landed on the moon. Because previously, it was many, many years ago, CFS did not exist. So that really makes us proud. How am I doing on time? Perfect. Thank you. So what's next? So this is all history about cool stuff, what we had, but what's coming? Many times when I go to different conferences, a lot of questions I'm being asked. It's very old school software. It worked. The beauty is it worked. So if it worked, like that's we as a human we have that tendency. If things work, why to bother, right? Why to mess with it? All great, works, no problems. You don't need to change it. It has enough to have our mission. So why should I bother with all this cool technology? Right? Nobody wants to take the risk being a human. But sometimes it's a need of hour and you have to catch up with technology, otherwise you'll be too behind at some point and you'll be obsoleted. So when I took over, started looking at stuff and thought, hey, what are the areas we are lacking? Because feedback from the community, a lot of people want to use CFS, but they want to have support from some cool stuff they are using nowadays, especially college kids coming out of the school, working on AI, machine learning, cyber, all that stuff, and say, oh, there's nothing in here. And they get disappointed. So thought, not a good idea, let's do that. And we have to work with you all and utilize your brains. Like, you might be expert on AI and machine learning, doing something like anomaly detection for cyber-related issues. And if we don't provide that kind of mechanism, we cannot utilize your brain. So let's utilize that, make this product, state of the art and supports everything what you need, and it's not behind for the next 30, 40 years. So decided a lot of requests coming from robotics side of it, within NASA and outside NASA. A lot of missions we do nowadays, especially in the harsh environment, are robotic. Might have heard about, we were doing a mission, it's called OSAM, that is like in space assembly and servicing, manufacturing and servicing, something like that. I forgot what this whole thing stands for. So I think in space, assembly and manufacturing. So basically this is a robotic mission to, so far what was happening? You launch a satellite, it does the job, this lifetime 20 years, and then when 20 years are done, you just abandon it. So that's what a lot of crap is in the space. So that's another problem area, we will not talk about it. But that's getting built there, and that's going to cause problem. So this mission was introduced like, hey, why don't we have something we can like refuel the mission if running out of fuel. If some maintenance problem, just go to the space and fix it. So this was the mission about, and it was like, that was the other one I was talking about. It's a multiple access robot, basically going to go to the mission, do the refueling, do any kind of manufacturing if required, fixing it, changing nuts and bolts, all that. So, and that was based on CFS. But a lot of things this research community developed for robotics, like, hey, that's not using because CFS does not support it. So in order to support those kinds of, and that's not just one, this is one example, the lot of missions we are doing robotic, like for the moon, for Mars, they need that kind of support. People, kids coming out of school, they are like living in the ROS2 world, ROS1 world. They have used all, especially if you study robotics, then you just doing all the ROS1, ROS2, you're not thinking beyond that. And all of a sudden, we got hired by NASA or any other company, and you are told, hey, use CFS to build the whole robot, and then you're, no, I don't know, I have never used it. So again, a learning curve. So utilize all those capabilities. I put it on roadmap. Hey guys, let's provide support. Cyber and robotic, security, autonomy. So autonomy is another big area we started focusing on. We have been supporting rule-based autonomy, like you script it, and you send one command, basically it's going to run the whole script, like ConOps, to do a full operation. That's cool. And actually we use that in very recent missions. Many other organizations are using rule-based autonomy in their missions. But what if we provide actual autonomy, onboard autonomy to make lots of onboard decisions? And the reason is, we have bottleneck for the network bandwidth. And you don't want to stream images from Mars or Moon to the ground. And that poses a requirement, like, why don't we add AI and deep learning type support and do data analysis just right there? And then only do the downlink whatever is needed. If some decision needs to be made, hey, make the decision just right there. And we have proven the technology. You can do 90% good job, not 100%, but you can do. You can drive autonomously in the crowded streets. So if we can do that, obviously, we can do a lot of those decisions in a space, and that prompted to provide support for artificial intelligence. So that's in my roadmap, and one day you'll have CFS that's supporting all deep learning type things, at least provide the framework. We are not going to provide a model, we are not going to do training for you, but we will provide a framework. So you go collect the data, you build the model, you train it, and then just integrate it with the CFS, and if you're doing object detection, your object detection framework is ready to be used. So I'm not going to go to this slide. This is what I talked about. The program model actually, I think it might be a good idea to brief a little bit on this. So far, CFS, as I said, it was born from Goddard, out of Maryland, near DC. So all the decisions about roadmap technology were being made just right there. But CFS is not a product at this point in 20 years, it's an agency product. It's not a product just for my center or Johnson or Marshall. It's a product for the community. It's a product based on agency. So basically, I changed the whole game plan, like, hey, agency, let's come together. And if we have to add a feature, let's say AI, then it should not be just me. It should be whole agency deciding to add the feature so it can meet the needs for everybody, not just a mission Goddard is doing. So that's the program model, basically. So we have a steering committee across 10 centers. I chair that committee, basically meet monthly and discuss the features. Hey, what we have today, what we need to implement in the next 6 months, and how we take community feedback. So sometimes we have maybe 10, 20 ideas from the community, and being a steering committee, we make the decisions like, hey, out of these 10, 20 ideas, what do you think? What is useful for the next immediate mission? So that is how we operate now. And We have large team now. That was always when somebody said, hey, you guys are not doing great support for CFS. Yes, I accepted happily. Sorry, we didn't have big team. But now I proudly say started like 2 team member. Now we have about 28 heads in my team. So we're trying to do anything we could possibly to support immediate needs. We follow agile. So when we are building something, if some priority comes in from any customer or any mission, we try to prioritize that. So goal is to best support the team missions. So I'm gonna pick on this, what we are doing on cyber. And we talked about all the space, everything so far, flight software. But without cyber, I think this CFS is incomplete. Even this keynote is incomplete. You guys are here to hear about cyber. And the mindset is basically an legacy mindset, I would say, is, hey, you build your software and everything gonna be behind the walls. You don't have to worry about it. So they were worried about it because the software is behind the wall. You cannot get to the spacecraft to do any mess there. But that is not true anymore. That is not true anymore. We were leader, like NASA was still leader in space, but there are others too now in the space. There is a presence from many other countries there, and if anybody decides to mess with your system, they can if you do not build proper security. So I started working with all stakeholders, basically from cyber world and within NASA, outside NASA. That's how I met Sam. So that's what I do right now. Like I meet people, understand, hey, what's out there? Did you guys do something better? I may need to work on this, and that might take me 2 years, and my mission is in 6 months. So what? Hey, let's just work together. This is community-based framework, and we have to come together as a community and fulfill these requirements. So this, all these 5 items we started touching, started from link encryption. Like, hey, let's do encrypt link first. Let's do step by step. We cannot deliver everything at once, but hey, what's the priority? Let's start with the link encryption. Let's encrypt that gate. Lock your main door first before we worry about rooms. So if your main door is not safe, there's still some things, because usually your main door might be much stronger than your room's door, right? Somebody can kick in and break the doors. But it might be difficult to break main door. So let's just make the strongest main door so nobody can get in. So that's where we started working on it, and actively be working on this. Then what happens next? If main door is secure now, what's next? Like, okay, now it's time to secure all the rooms, or living rooms, or family rooms, just to make sure, even for some reason somebody breaks the main door, they are not able to get to our rooms, then there might be some treasure there. So that's our next in line. Hey, let's do that. Provide a zero trust architecture. I'm not going to trust even my brother. I'm not going to trust even my parents. You have to identify yourself before I say, okay, you are the one. So that's what your zero trust architecture. You don't trust, zero trust for anything. So that's the next big thing coming up, working with many stakeholders to provide that support. And let's say we provided all that. What about legacy system? Even somebody is able to break your rooms. There's a treasure there. Now what? So that's my next item, saying, now how quickly you can detect that. If somebody passes your third stage, second stage, should be able to detect. And once you detect it, you look at notification alerts, notify all the stakeholders, try to mitigate uh, any events you're detecting. But even you detect it, try to mitigate it. Do you have something already built into your system that will protect your mission? You are on the moon. You already spent billions of dollars. And so if somebody breaks in, what do you want to have? Very last thing you want to have is fail your mission. You don't want to fail your mission. So build something in your system, and that's the next stage, provide mission recovery. Even something bad happens, do you have any means to recover your mission? You don't want to fail that. So you have to think through all those stages. So that's what my next phase is. Like, even all that happens, breaks, now you're still able to recover your mission. And finally, what's left? There's something is still left. Your mission can still succeed, all that happens with all this support. But what's left? Like, where are you building this system? You're building system somewhere in the ground, writing all this code, using all the piece of good hardwares. You are creating simulators, emulators to expedite your system development. And you are very careful, all that, but still, are you protecting your system where you're building this code or not? Did you verify the hardware you're using does not have some malicious code? Right? Maybe somebody's smart enough and said, how are you going to use the switch? I know that you're buying this switch. So if I'm not able to target your system, I can target the switch you're using in your system. So basically, if I'm able to break into the switch, let's say, now I got access to your system where you're building your code, you're doing your CI/CD pipeline, and I'm just breaking into your system. I already put it there. So now what? Basically, you got infected. So that's what, like, your DevSec ops comes into play, your supply chain comes into play. Like, make sure you are protecting your supply chain. You are aware what you're using. Nowadays, you cannot trust on any hardware you're using. It's like you have to be very careful, very mindful of what you're using. The servers you're using, you should be mindful of what kind of server you're using, putting your whole code. And you do not have enough protection. Somebody gets in, basically they have access to your code. They can just go alter things. So with that, that's the whole thing. Like, I think this is very, very broad, very top level, but that's where our focus is. Like, in the future, when you have CFS, they provide all the support to secure a mission at every stage. So another work we are doing on interoperability. So I mentioned ROS2. It's very heavily used. Some of the system, even within NASA, they developed using ROS. And now, if I tell them, hey guys, can you go rewrite your software? Because you have to use CFS for one instrument, and your other robotic system is written in ROS2, nobody gonna like that, right? And maybe they are forced to use CFS for one of their instrument for any reason. Could be like gateway. You might have heard about, we are building a gateway which is the ISS version for the moon. So we'll build the gateway. I don't know, in 2 years or 3 years later it's going to be launched. But that gateway has requirement. When you build anything, you're trying to dock to gateway, basically you must use CFS. So in that scenario, like if some third party want to send something to dock and do some research, and they are using their own product, non-CFS, now what? You get stuck. Either they have to rewrite the whole thing or just roll out their own interface. So that's the reason we started to rethink, like, hey, we cannot say, hey, we don't support. That's not the answer. What we have to do is we have to make interoperable. So there are already predefined interfaces you can use to talk to if you need to. And so another flight software framework is F Prime, which is from JPL or Jet Propulsion Lab. So that's another thing. A lot of mission, those were done like Mars helicopter. It's powered by F Prime. So what if we have to interface with the helicopter, some of the mission? Now we can't. So that's the whole plan here, roadmap to support or to have those pre-built interfaces. If you have to use it, it's there. You can still talk to third-party frameworks. CCSDS, this is a standard, so CFS uses this standard. So that's why if you are not using any specific NASA-based ground systems, you can always use any third-party ground system which follow the standard. So that's the beauty, like you can utilize, as long as your ground system follows CCSCS standard, you can interface with CFS-based flight software. So another cool operating systems we are trying to work with Lincoln Lab to provide some kind of support to magnetite and biotite. So right now we do not have support, but we are thinking about it. Like, hey, why not? It's a great software, a great operating system. It is built security in mind. So it would be cool to run CFS on biotite. And another chess. This is another flight software framework created by actually Lincoln Lab under DoD, and we are thinking like, hey, some of the system might be powered by chess. So what? Are we not going to talk to chess? That would be a problem. So the thought is, hey, let's work on it and provide some kind of interface that can talk to chess as well. It's not just chess, but any other frameworks or operating system are supported by space community globally. One by one, start adding support, so we can better support the community going forward. Excuse me. Are we still good on time? I think nothing much left, but okay, I think, okay. Yeah, I think we are good. So there are other cool features we're creating, like DTN, you might have heard about. DDS is another support. So that's what I was talking, like when you have to provide robotic support or ROS2 support. So if you know ROS2, probably you know ROS2 is powered by DDS, which is Data Distribution Service underneath ROS2. So we started working on to support DDS as backbone for CFS as well. So this way, when you are using any robotic system, you can always use proprietary software bus versus DDS to support any robotic mission or any like ROS2 based or DDS based frameworks. Talked about rule-based autonomy. So one last thing in the slide I want to talk about is, like, I did not mention, like, NASA has very low power custom built boards, space hardened, radiation hardened, obviously. And we have been running all these missions on those small boards, even less powerful than your today's Pi 4 or 5. You'll be surprised to see that, but still we were able to do that. And why we were not able to do that or support all these autonomy or custom decryption on board, all these require resources. And we didn't have resources. And we didn't need that time, so there was no need. So if you have to support artificial intelligence today to do onboard autonomy, and if you have to go with your existing hardware, answer is no, you cannot do that. It does not have enough horsepower to run your inferencing models. So NASA decided to partner with Microchip Probably you know who the microchip is, like some chip company. Uh, so we partnered with them and come up with new age hardware that could support all these beautiful technology out there. So that new board, excuse me, that new board is called HPSC, High Performance Space Computing. So, so it's not big enough, but you can see microchip HPSC. So this is coming out very soon. It's, I think they are in the final stage. They started rolling out orders probably in 6 months. It will be available to use. And I created actually a cross-center team to port CFS to HPSC hardware. There are 5, 6 centers working together, developers from different centers with different expertise. So I created a sub-team that would create CFS for HPSC. And part of that basically provide everything to utilize any features this board has, like it has NPU, neural processing engine, or unit, whatever you call it, to make your inferencing much easier, smooth, vectorization, all that. It has encryption, decryption, like hardware chip, like SoC there to, you can do like encryption, decryption faster, and implement like hardware-based decryptions technologies. Very fast. It's a multi-core system. That's another point I wanted to make is CFS was not meant to be multi-core system. Always ran on single CPU core, and we never needed that. Like with small board, one core single core system always worked. We never bothered about it. But now it's not going to if we do not provide support within a few years. So this is a multi-core system, and you can run things in multiple cores. You can secure, like you can distribute your applications. Some high or sensitive application, you can put it on one core, protect it, and nobody can get access to that partition. So all that you can do with this new hardware. Other thing is like performance-wise, you can see it's about 100 times performance increase. And it provides, if you might have heard about ROC v2, it's some Ethernet standard for very, very high bandwidth data transfer. So this provides ROC v2 support. And excuse me, for the maintenance side, basically, like right now, as I said, we're supporting FreeRTOS, Linux, RTEMS, VxWorks, working with Green Hills for integrity support. Zephyr is another Wind River's operating system getting popular these days. So all these are in our pipeline to be supported. Safety and reliability, hey, we follow like this mission, I mean, CFS is used on human-rated missions, like Artemis, basically. So safety and reliability is basically top requirement here. And we have certain standards, like we call it Class A, Class B, or human-rated missions. And like even Gateway, human-rated missions, humans needs to go there and stay and do experiment. So for we support those kind of missions. And for that, like we take safety reliability very seriously, and we try to work through every stage. We design different testing standards, collect all that data, so like test artifacts, so that way you can get certified. And if you're not getting certified, you're not flying humans. With that, as I said, CFS was designed from the start. Actually, not that big evolution, but it went beyond expectations. And there are, excuse me, there are still few engineers who originally worked on CFS. And those people are in my team. It's very interesting to talk to those guys. Like, did you ever think about it? Like, this CFS is going to be that big one day? And answer is no. As I just said this framework is like very heavily used by DoD, yeah, NASA, across NASA agencies, other government agencies in foreign countries also. Commercial space, like a lot of commercial companies, I directly work with them. They use CFS, and big players like Blue Origin and Intuitive Machine, even Boeing and aerospace, all those companies here and there using CFS. So, with a final thought, like, hey, CFS team is very much aware with technology nowadays, and trying to catch up each and every bits and pieces of technology, and basically prioritizing based on mission needs. So that's where we are. So that's our mailing list, CFS-program. Like, if you have any question, you need collaboration, you want to talk to me, this is the email, you can send it, and we can go from there. We provide trainings. I think good thing to tell you guys. We provide CFS trainings called CFS 101. You can look at CFS website. It's like we launched it like 2 or 3 months ago. I'm trying to change the mindset from previous 20 years generation to now. It provide everything, whatever we can to support you. And if you and your team needs any kind of CFS training, please reach out to me, and I'll work with you to get trained, at least basic hands-on, hey, what CFS is and how to write hello world in CFS. And to the right, my LinkedIn page, if anybody wants to connect to me. And thank you.
Thank you very much for that talk. We have about 8 minutes or so for questions, so please feel free, come up to the microphone, state your name and affiliation, and ask away.
I was surprised, like I was not too good. You understood everything.
Thanks for the presentation. I was wondering, so what fraction of the CFS development is done in-house versus like by contractors, for example?
So, I mean, that's a very good question. And contractor, when you say contractor, you mean NASA contractor within the team versus, or
Third parties, mostly.
third party? Yeah. So, mostly developed by our team, and we have a process for PRs, like we have GitHub presence. So let's say you are doing for your company and something, you thought, hey, I think there's a bug here. So you can always open a PR and send your, usually we get so so many PRs every week, and we have CCB, and so that goes through all those PRs and decides, hey, which one is good, which one we should take, which one we should push for a few months or something. So we do support, and a lot of things keep coming from third party.
Thank you.
Thank you. Great talk. I'm Kangkukji from UT Dallas. First of all, I want to actually appreciate your efforts to share the CFS. Actually, my team looked into it, tried to find a bug or any kind of errors. It was really, really well maintained, and it was really good. It was really hard for us to actually fuzz and then get some errors out. I have some related question about your effort to open source and like gathering some community efforts on it. But whenever we are trying to actually study and look into your code bases, some of the critical modules that we think are security sensitive, those are proprietary and then was not open. So that actually, that was some kind of the hit that we, like a wall that we hit some every now and then. So my question here is that from a cyber person, I found that so aerospace and then space domain was in a somewhat closed culture.
Right.
Compared to us. What is your take on this? For us, like it is, we believe the security by the open. So I don't know, like what is your take on this, or the your agency's take on this? I hope this makes sense to you.
Yeah. So, excuse me. I just said this was like a lot of bureaucracy involved when you are doing things open source.
Okay.
And probably you might have seen that the CFS, the last release was somewhere around 2020.
Yeah.
So our Equalus RC1, which is our latest release candidate, is stuck, basically working with lawyers and this language, that language, financing. So that's the one problem. Even we have updates.
Okay.
We have bug fixes. Like, hey, my team is working day-to-day basis. We might have got the fix from somebody before you encountered, or you encountered that bug and send it to us. Yeah, we update the code, but now we are not able to put it out. And I'm trying to fix that problem. That's what I'm working too hard on that. Hey, this is not good because our community is suffering for, and this is like duplicate efforts. I personally seen one person submitted a fix and then my team encountered that. They, excuse me. They found the same problem. So that was the fix. Actually, my team found the fix first. They fixed it, and then other community member had to go to same pain to fix that. So I'm trying to fix that issue in order to mitigate that problem a little bit. What decided, like, open up another government release.
Okay.
And back to your question, a lot of things are like closed source, especially cyber support. When you provide cyber support, cannot open source. It's ITAR, export control issues. They would not let me do it. I would like to, but they would not let me do that.
So what would you suggest us to do as a community?
Yes.
Or something that you want to ask?
Yeah. So definitely, I would say if you have those needs, certainly reach out to me and I'll work with you.
Okay.
I'll work with you. And that's what, like, I work with many in need. Like, hey, I need this feature, which, excuse me, just keep coming. Like, they need something. So I work individually with people. We cannot open source. Okay, but given all the circumstances where you come from, all that type, like organization-wise, hey, I can release stuff to you as long as you qualify. So we do that. We work with commercial companies. We work with many part of the DoD. Like, hey, it's not open source, but we know you need it. So we work with you on the case-by-case basis to support you.
Yeah, I have some follow-up for that, but I think it is better for me to take it offline.
Yeah, we can talk. I'm here whole day. Yep.
I'm Hyung-seo from Indiana University. Yeah, thanks for
Awesome.
your great talk. So I think you briefly mentioned about different type of attack vectors, such as supply chain issue, also any buggy code line. But in NASA's point of view, I wonder what is most seriously considered attack vectors?
So I think I cannot talk much on that. As I said, basically we're trying to protect. There are some things like certainly, and we know that, like, hey, what happened, what's happening in the cyberspace. We are very much aware. We have large teams looking into all that. So based on all those, basically all these designs are coming from. Like, hey, few years ago, we were not thinking about all these. But based on those incidents, hey, what's happening? What are the attack surfaces? Where we can protect? So all that we are very much focused on, and whoever customer we could support to provide these solutions, we will. So that is why I said I'm working directly with the customers to support them. So one more thing I want to mention might be useful. Like, for that reason, I proposed just not having open source, but also provide another CFS version, which is like, they call it distro C or government use only. So that way, a lot of things which are export control, which are like, I cannot share open source. So now, if you're eligible for government source, we can give you access. Now, you take this supports everything you need. Even all those are export control. But again, this is individual basis.
Thank you.
Hope this answers the question. Any other question?
Yeah, hi, Dave Ballinson with USC ISI. One of the questions that kept popping up in my mind is hardware support and requirements. We often hear about, low size, weight, and power and all
Right.
that, and yet it seems like a lot of what you were talking about, including supporting machine learning models, would sort of require, greater computational power. So I'm just curious if you could comment on that.
So I mean, briefly, as you mentioned, this HPSC. So that is the answer to many of those questions. And that hardware support, like, I mean, it's massive. It's open source, actually. You can type in NASA HPSC, you'll find the full documentation, what it can do. You'll be surprised. It has support for roughly all domains, networking, your, including FPGA. If at some point we have to create custom hardware support, you have FPGA there to support your needs. Along with like SOC for AI, SOC for encryption decryption. So it's a massive hardware. Most importantly, like radiation tolerant. So, like, people started talking about it, and that's why we are very serious. As soon as it becomes available, we have the support. So any future missions, and people started asking, like, hey, can we use this for our next mission if it's coming in 3 years, 4 years? Right now, it's not in the market.
Okay, great. Thank you.
So that's where we're coming. All this cool technology, basically based on that hardware. If that hardware is not available today, we would not be able to support, even if we promise. So that would be a lie. Any other question, guys? No, thank you so much. Again, please reach out to me if you have any question, and email me if you're not able to get hold of me today. I'm here whole day and be happy to talk anything about CFS or space. Thank you.